In this video, we're going to see where these identities comes from. So consider a circle of radius 1, and let's say the angle here is x. So if you draw a straight line down here, then you know that this height is sine of x. You know that this base here is cos of x. So by using Pythagoras on this triangle here, 1 squared, the hypotenuse squared, equals sine squared plus cos squared. So looking at this triangle, we can see that it would give us this thing here. So this is done. Now we need to consider this. So to consider this, let's say the angle here is currently at x. Draw a tangent line at this point. So drawing a tangent line at that point, let's just say it looks something like this. So this will, if this line here is a tangent line at this point, then this must be 90 degrees, and also this must also be 90 degrees. So let's look at this triangle here. Let's look at this triangle here. I'm just going to enlarge it, so it will look something like this. This is 90 degrees, so that's this bit here. The radius is 1, so this is 1, and the angle here is x. So this angle here is x. So the question is, what is this length here? What is this length here? So we want to know the length. Let's call it w. So the length w would be tan. So you tan the angle equals the opposite over the adjacent, which collapses down. W collapses down to 1 to w here. So w, which is this length here, is tangent of x. So this length here is tangent of x. The next question is, what is this length? The next question is, what is this length? So let's just call it z here. So z would be, well, if you look at this here, this is cos. So cos the angle, which is x, equals 1 over z. 1 over z. So now you want to get z on its own. So z equals this. Z equals 1 over cos of x. Well, 1 over cos of x is secant of x. So this length here is z. Sorry, this length here is well, z is secant of x. So this length here is secant of x. So now looking at this triangle here, we can use Pythagoras again. So the longest length is this secant of x length. So secant of x squared equals tan squared plus 1 squared. So now we know that this will always be true. Okay. So consider this small triangle. If you want to prove this, consider this triangle here. So your tangent line. Consider this triangle here to show that this will always be true. In the next video, we will look at this one here. Okay.